Alright guys, welcome to our lesson on limits. When does a limit exist? And that's a question that perhaps a lot of students have questions or confusion on. So let's go back to the basic understanding of when a limit exists. The limit of the function exists when the limit of that function as x approaches a from the right equals to the limit of that function as x approaches a from the left. Graphically, let's take a look at a few graphs of functions where a limit exists. So if a function is continuous, then the limit does exist at that point a, because as x approaches a from the left equals to x approaches a on the right. Right? Now, when we talk about limit, we don't care about the specific value, function value at that point. All we care about is what value does the function want to take on at that point. So the limit of a function that is discontinuous at a could also exist, because the only thing we care about is what function value does the function want to take on when it's getting close to a, and that's what we mean by limit, getting close to a but not as at a. All right, so therefore in this case the limit of this discontinuous function also exists at a. Looking at this last discontinuous function, if you look carefully at a, both graph as it gets close to a wants to go to infinity. This is a discontinuous function, and therefore the limit of this function does exist, which is infinity. Now let's take a look at some functions where the limit does not exist. Okay, so I have two sketch of functions that are discontinuous, but the limit at a does not exist. If you look carefully of this first function over here, as x approaches a from the left, we notice that it takes on some value. And as x approaches a from the right, we know that it takes on another value, but this value happens to be different, and therefore the limit does not exist. The function wants to take on two different values at a. Here's another example of discontinuous function where the limit does not exist at a. If you look carefully, as you're approaching a from the left, the function tends to or wants to take on infinity. However, when the function approaches a from the right, notice that it wants to take on negative infinity, and therefore those two are not the same. Limit doesn't exist. Here, we're taking a look at the limit of a constant function. And basically, I'm going to do a quick sketch so that you can kind of get a graphical side of what I meant here. This is 1, 2. So here's a constant function. We want to find, hey, what is the limit of this constant function as x gets close to 2? Well, it doesn't matter, because this value doesn't depend on what that function value is. And if you look carefully here graphically, as x gets close to 2, the function takes on 5. So in this case, the function, this is just equals to 5 because it takes on the same values everywhere. So that's the limit of a constant function. In example 2, we look at the limit of a linear function, or the limit of a power function. In this case, we know that this is the graph of a line, and we want to know, hey, what is the limit as x gets close to 1? All right. This is a continuous function. When a function is continuous, the limit will exist, and therefore you can take a look at it graphically and know that it exists. And finding it, it's actually pretty simple. If you know it's continuous at that point, all you have to do is plug in the value. So in this case, we're going to have 3 times 1 minus 2, and therefore the limit is equal to 1. Right? In example 3, we're taking the limit of rational functions, but x is going to tend to infinity, so x will get as large as it wants. Now, looking at this problem, you might think it's actually complicated, but it's actually very simple and very easy, because when x gets big, these terms are really meaningless. So as x gets big, the only thing that matters is the leading degree of the numerator, or perhaps the term that contains the leading degree of the numerator, and the term of the leading degree of the denominator. In this case, when x gets big, the only thing that matters is 2x squared over x squared. That's the only thing that matters. These things are going to be very small, and therefore it doesn't really matter. So once you know that this limit is equal to the same thing as this limit when x gets big, you can just rewrite the leading term of the numerator and the denominator. Now cancel these out, and therefore you get 2. Let's take a look at a classic example of our number 4 here. In this example, we're looking at the limit of a rational function of 1 over 1 minus x. And if we take a look at the graph is going to look like this. The graph of this function will have a vertical asymptote here, and therefore as x approaches 1, if you were to graph this function from the left, you're going to see that the function is going to be positive infinity, so it's going to look like this. And you can verify this with a graphing calculator. And as x approaches -1, it's going to go like that. So the question is, by looking at it graphically, you can kind of see that the limit of this function at 1 does not exist, because when the function approaches, when x approaches 1 from the right, it's negative infinity. When x approaches 1 from the left, it's positive infinity. Therefore, these two limits, the left limit and the right limit, takes on different values, and therefore we say that the limit of the function does not exist. If you're not, so in order to prove this, you have to be careful, get a visualization of what the graph looks like, and then you can show this by first, you can state that the limit doesn't exist by first showing that these two are not equal to each other, and these two are not equal to each other. And once you have successfully stated this, then you may conclude that it doesn't exist. And the way how you stated this is actually pretty simple. You just go with the limit as x approaches -1, 1 over 1 minus x, limit as x approaches 1 on the right. This is going to be 1 over 1 minus x. Over here, you can plug in anything that is really close to, and I'm going to assume that by looking at this statement, you're plugging in a value from the left. Okay, so remember, here's 1. You're approaching 1 from the left, and you're plugging in a value that's close to 1, but not 1. So when you plug a value that's close to 1, this number right here will be 1 over a very small positive number. And when you take 1 divided by a very, very, very small positive number, you actually get infinity. Over here, you're plugging in, you're approaching 1 from the right. So if you look carefully, here's 1, and you're approaching 1 from the right. So you're plugging in, you're plugging in a number right after 1. So if you plug in a number right after 1, so you're saying 1.00000, say that a billion times followed by a little 1, then this will become a very small number. Very small negative number. And 1 over a very small negative number will be negative infinity. And therefore, you can kind of see that these two are not equal to each other. Therefore, the limit doesn't exist. So we want to know what is the limit as x approaches 0 of sin of x over x. it turns out that this limit is equal to 1. Equals to 1. The reason is, when you take a look at this graphically, at around, when it gets close to 0, the function will oscillate a lot. And then, but when it gets 0, for some reason it just tends to behave really nice, and then it will oscillate continuously. The only way for you to kind of see this at the moment, assuming that you haven't had Hopital's rule, is by using a calculator and zoom in at 0. And if you zoom in at 0, you'll see that this is equal to 1. So using these, we can actually generalize these. It turns out that, so in general, it turns out that whenever you take the limit as x tends to 0 of sine of a number x over that same number x, that tends to always be 1. Right? And that can be proven by looking at a calculator, analyzing the graph on a calculator, and you're going to see that this is true. If you have other questions, or if you have problems that you want me to help you with taking limits, make sure you can leave a comment, and then I will get back to you, and I will work it out for you.